In this lesson, you will be learning about the reaction quotient called Q. So first, let's look at this equation. A plus B goes to C. If you have 1 molar A, 1 molar B, and you have 0 C, which way will this reaction proceed? Of course, it will go to the right to produce some products. If initially you have 0 A and B, but you have 1 molar C, which way will this reaction proceed? You're right, it will go to the left. Because it can go to the right, you don't have any reactants. Okay, now if you have this reaction where you put, let me just take this out, where you have 1 of A, 1 of B, and 5 of C, which way will this proceed? Will it go to the left because you have too much products, or will it go to the right? You really don't know. You need K equilibrium to find out, to see the ratio of products over reactants. If K equilibrium equals 5, then if you plug in products over reactants, 5 divided by A is 1 over 1, that equals to 5. These two numbers are equal, that means you are at equilibrium. The reaction will proceed forward and reverse at the same rate. So you are at equilibrium. Okay? There is something we call reaction quotient. The reaction quotient is the same formula as K equilibrium. It is also products over reactants. But the reaction quotient is the same ratio, but you may or you may not be at equilibrium. It is for a system at any point of the reaction. So in this case, if you're not sure you're at equilibrium, then you plug it into the same equilibrium expression, but this time you call it Q, or reaction quotient. 5 over 1 times 1 would be 5. That means if Q, which is 5, is equal to K equilibrium, that means you are at equilibrium. Okay, so here's another scenario. You have initially 1 of A and B, and you have 10 C. K equilibrium is also 5. Are you at equilibrium? Are you going to the right, or are you going to the left? Okay, what do you think? Okay, for this, it's really easy to see that you're supposed to make 5 products, but you made too much. So it's obvious it's going to go to the left to get rid of the products. But how can we tell using the reaction quotient? The reaction quotient is Q is equal to products C over reactants A and B is equal to 10 over 1 times 1 is equal to 10. Since Q is too big, bigger than K, that means you have too much products, which means you're not at equilibrium either, which means if you have too much products, you're going to the left. Okay, let's do, so this says, what is Q? Q gives the same ratio the equilibrium expression gives, the same formula, but for a system at any point of the reaction, it may or may not be at equilibrium. To calculate Q, all you have to do is substitute initial concentrations, which I did here, on the reactants and products into the equilibrium expression, which is this right here. Okay, so let's do a problem. It says at 448 degrees Celsius, the equilibrium constant Kc for this reaction is 50.5. So I'm going to write that here. K equilibrium is equal to 50.5. And from this number, I can tell that since this is a ratio of products over reactants, I can put a 1 right there just to, compare. It looks like when the reaction reaches equilibrium, the reaction is all done, you will have more products than you have reactants. That's what that number means to me. Okay, so it says, if we proceed at, it says predict in which direction. So they're asking you, are you going to the right or are you going to the left? Predict in which direction the reaction will proceed to reach equilibrium at 448 degrees. If we start with 2e negative 2 mole of HI, and I wrote that here, 2e negative 2 moles, 1e negative 2 mole of H2, and 3e negative 2 mole of I2 in a 2-liter container. So what I will do is I'm going to go ahead and divide all of these by 2 liters to get me to molarity. Okay, so then I'm going to go ahead and start. 1 divided by 2 is 0.5. 0.5 e negative 2 molar. So this is my ice box. This is initial. And I'm going to put a big M right here so it reminds me I'm at molarity, not moles. 3 divided by 2 is 1.5 e negative 2. And 2 divided by 2 is 1 e negative 2. Okay. So which direction will this go? So is it going to the right? In this case, I would do minus x plus x, or is it going to the left? In this case, I would do minus x plus x plus x. I don't know. So I have to first figure out which way it's going. And this is pretty much what they're asking. Okay. So just make this. Okay. So all I have to do is calculate Q. Q is equal to products, which is HI, squared, divided by H2 times I2. Okay, I solve for that. I'm going to get 1e negative 2 squared divided by 0.5 e negative 2, which is, this is H2 right here, and I'm solving for H2. Now I2 is right here, 1.5 e negative 2. And I'm going to get a number. Let me go ahead and solve for that. I'm going to get, I got 1.33. This is my Q. Okay, so let's think about this. This is my Q, and this is my KEQ is 50. Am I at equilibrium? You're going to say no. Since Q is not equal to K, you're not at equilibrium. And then it's going to ask you, it says, and predict which direction the reaction will proceed. Is it going to the right or to the left? Well, let me think about this. This is a ratio over 1 of products over reactants. As you can see, I don't have enough products. Not enough products. Because the ratio of products is 50.5 to 1. Therefore, if I don't have enough products, this reaction will go to the right. And that is pretty much all they're asking. Which direction will it go? You're going to say it's going to the right. Okay? If they wanted you to go further, if it's going to the right, then that means you're going to do minus x here, minus x here. You're going to use these to become this. Okay, but they're not really asking that. Maybe for a future problem. If it's going to the left, then it would be a different story. You would put, you're using the products to make some more reactants if it were going to the left. Okay? But you don't need that for this problem. All you have to say is it's going to the right. Okay? So over here, comparing K and Q. So if KEQ, just to show you what happens, if KEQ is 50.5 and Q is smaller, let's say like the problem above, 1.33, that means this is over 1, this is over 1, this is products over reactants, this is products over reactants. This tells you you don't have enough products. Not enough products, so go to the right. Okay, if KEQ equals 50.5 and Q is equal to 100.5, let's say you did the problem, and you can put the ratio in just so you can see this is products over reactants. This is products over reactants. You compare this number of products in Q and this products for the KEQ, you have too much products. So go left. This reaction will go to the left until it gets back to equilibrium.